All right, quick review of what we talked about. Right? Obviously, we talked about what is a sequence, right? Sequence is a series of numbers. Sometimes there's an end to it. That makes it a finite sequence. Sometimes it continues on forever, and that would be an infinite sequence. Then we talked about finding the specific terms. So this time it was 5 terms. We plugged in 1, then 2, then 3, then 4, then 5. And then we said what would happen if it just asked for like the 10th term. We would just plug in 10. Then came convergent and divergent. So convergent goes closer and closer to a number. It continues on kind of a direction, whereas divergent does not necessarily do that. Sometimes it goes negative, sometimes it goes positive, sometimes it's a fraction, sometimes it's a whole number. It's not as much of a distinct pattern. And the series is the sum of the sequence, which is sigma letter. This is kind of where we left off. We talked about that these are sort of shortcuts. Sometimes it's faster to just find the sum. And to do that, we start with a number at the bottom, the number which is a 1, not an L. We start at the number that's the bottom, we plug that in, and we stop at the number at the top. For the first kind, this was our kind, like, let's just say that it was just a number. So it said sigma, there was, I don't even know, 10, I equals 1 here, and the number 3 is there. So if there's nothing, no variable next to it, then we simply just take the top number and multiply it by the number on the outside. This would be 30. That would be the same thing as adding 3 10 times. Then we said what happens when there's a number on the front. So let's say, a number and a variable. So let's say we had this. I starts at 1, and this is like a 2x. That means we would start at 1, plug in, we'd get 1, plug in 2, plug in 3, plug in 4, plug in 5, and then we'd add all those numbers together at the end. Or we'd say 2 times I equals 1, 5, just x. So we'd plug it, we'd add up 1, then 2, then 3, then 4, then 5, and then we'd take that sum and we'd multiply it times 2. That's kind of where we left off, right? Okay. So then the next set is saying, okay, what happens if I have a sum? That a and b can just be 1. They can be 1s, okay? But I is your variable. They can also be a different number. It could be a sum or it could be a difference. So the generic form of this, like without the shortcut, would be something that looks like this. Let's say this is 4 at the top. Let's say we start at 1. And let's say this is 2x plus 1. So if I had something like this, one way to do it without this little shortcut, right? One way to do it is start at 1 and go all the way to 4 and plug them in. So I would find a is 1. 2 times 1 plus 1 would be 2 plus 1, which is 3. I'd find a as 2. So I'd get 2 times 2 plus 1, that'd be 4 plus 1, which is 5. Then I'd do 3. 2 times 3 plus 1 would be 6 plus 1, which is 7. Then I'd do 4, and that's where I'm going to stop because that's the top number. And I'd get 8 plus 1, which is 9. And then at the end, I'd add all of these together. So 3 plus 7 is 10, plus 5 is 15, plus 9 is 24. So that's one way to do it. And if the number on the top is not too big, I actually don't think that's that bad, right? Sometimes the shortcuts take longer, but if their number at the top was a bigger number, then it'd be a little bit harder, okay? The other option is to split this, ladies, is to split this into 2 statements. So that if I had 4 at the top, I equals 1 of 2x, and then I add to that 4 at the top, I on the bottom, and the positive 1. So this becomes 4 because I get the 1 times the 4. This one I would plug in. I'd get 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4. 10 plus 10 plus 4. And I get 24. So you could take that statement and you could break it apart. You could even take this statement and do what we said with the last thing. I could take the 2 and push it to the front. So I could do 1 plus 2 plus 3 plus 4, then multiply it times 2, and then add the 4 from the end to it. So this is just saying you could basically take apart that sum and make it into 2 summations. And you can do the same thing with subtraction. So that if it said again, maybe 5 at the top, I equals 1, and it said 2x minus 3, then I could do the same thing, 5i equals 1, 2x, and then it would be a minus 5i equals 1, 3. So I'd do the 2x, which we just figured out was, oh no, there's a 4 there, so I'd have to go one more. So I'd do 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, minus 5 times 3, which is 15. 2 times 8 is 10, 4 times 6 is 10, plus a 10, that's 30, minus 15, which is 15. Or I could take and plug in a 1, take and plug in a 2, take and plug in a 3, take and plug in a 4, take and plug in a 5, and then add them all together at the end.
For the one where you multiplied the 3 and the 5,
yeah.
What do we do if it isn't I equals 1?
Then it would be one less, well, it depends on what it is, actually. So the rule is that the number on the bottom, like if you're trying to figure out how many terms there are in that, which would be what the top is, if it's not 1, then it's the top number minus the bottom number plus 1. So whatever, if you don't want to count it out, because sometimes they get big. So if it's 5 and it's 1 down here, then my n, or number of terms, is 5. But if that changes, let's say it's sigma and the 5 at the top and this is n is 2, then we can count how many there are from 2 to 3 to 4 to 5. Like you do it like that. Or you do top minus bottom plus 1. So it'd be 5 minus 2, which is 3, plus 1, which is 4.
Thank you.
You're welcome. And that's going to come into play, like we'll talk about that a little bit more, because when we do something with arithmetic, which is in 11.2, you definitely want to know those numbers of terms. What if what? Sorry? Then it would be 1, so then there's going to be one more than the top number. You'd plug in 0. The first one would be 0. Yeah, so if you're plugging them in, you would start at 0 and stop at the top number. But if you're trying to figure out the number of terms, it would still be top minus bottom plus 1, which would be 5 minus 0 plus 1. That's 6. Questions on this slide?
So it would be plus and minus, whatever.
We just said you could take something that's a sum and you could actually take it and split it into 2 partial sums. So if I had this, I can actually take and split this into 4 I equals 1 of 2x plus 4 over I equals 1, 1. So you could take this and split it at the plus.
So you don't have to do the plus or minus?
Right. You could do, and I said if it's only a couple of terms, like this is only 4 terms, it actually is probably not that much of a shortcut to just keep and plugging them in. But just know that this can be done. So when I work through some of the examples, I'll do both ways. Okay, so here's some more rules. So if you are adding from, if they are consecutive integers, so if it's 1, then 2, then 3, then 4, then 5, so on and so forth, okay, then you can find the shortcut of it by doing n times n plus 1 over 2. N is the number of terms. So if I had a single number next to it, like if I just had the variable next to it, right? Like if this said 5i equals 1, and this was just x. Then I could take and plug in 1. I could take and plug in 2. I could take and plug in 3. I could take and plug in 4. I could plug in 5. And then I can add them all together. Or I can do this. N times n plus 1 over 2. N is the number of terms, so if the bottom is 1, it is the top, which in this case would be 5, times 5 plus 1 over 2. So this one gives me 3, plus 3 is 6, plus 4 is 10, plus 5 is 15. This would be 5 times 6 divided by 2, 30 divided by 2, which is 15. So either way, if it's just a single variable on the front, I can either take and plug those numbers in, plug, add them all together at the end. Or I can use n times m plus 1 over 2.
So, this is like the first example. This is the CN example.
No, there's a variable there. C was a letter. I mean, C is just a number, but I is there. I is saying there's a variable.
Oh,
So like this, just a variable.
so it's like the C.
It's not, because we did a product on that one. So this isn't like any of the ones from the last one, because we had a number multiplying by that on the last one.
Do we have to use these shortcuts?
No.
to find them?
There's going to be times where it's going to be easier if the big number is huge. If the number at the top is huge, you're not going to want to plug it in that many times. So this is going to be way shorter, right? If I gave you this, you're not going to want to plug in 1, then 2, then 3, then 4, then 5, then 6, then 7, then all the way up to 100 and add them all together.
Yeah.
You would definitely want to use n, which is 100, times 100 plus 1 over 2. So you get 100 times 101 over 2. You could simplify that. 2 can get times 50, go into 150 times. And then I'd get 0, 5, 0, 5. Way faster than doing 1 plus 2 plus 3 plus 4 plus. If it's a small number, not a big deal. That's what I was saying before. Like the small n's kind of don't really, these shortcuts don't cut out a whole lot of time. But something that's big like that, it's way faster to do that.
This is,
On the test, will we have like big numbers?
You're gonna, when we haven't major tests yet, but I'm pretty sure you're gonna see some big numbers. Yeah.
this is, okay. I'm looking at it and I'm trying to understand it.
Mm-hmm.
And it looks like you're doing 1, because that's what I is, right?
Mm-hmm.
Through n, which is 5,
Mhm.
plus all of the numbers,
Mhm.
1 through 5, which is going to give you the new n. Or no, because that's n is 5.
N is 5. If you add them all together, the answer is
So then
15.
what do you get for
Then the answer is 15. So this is doing it one way. This is taking and plugging in 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, and adding it together.
Or do
Or you do this little
5 plus
shortcut.
1 divided by 2.
Correct. And
So
when there's only
that's the shortcut, or the shortcut is the one we did first?
the shortcut's the second thing. The plugging them in and adding them together is how you do a summation, no matter what kind of summation it is.
Oh, yeah.
Yeah.
That's why I was confused.
Yeah.
So the shortcut is n times n plus 1 over 2.
Correct.
Oh, okay, that was,
But it only works if there's just a variable there.
so it's like, in my brain, it's like the second one of the first slide without.
But you'd have to push the number to the
without
front.
coefficient.
So you'd have to push the number to the front. Right? So I could modify this.
So if it was,
So let's say it was this, right? 100 on the top, I equals 1 on the bottom, and let's say it's 3x.
so I could put the 3 in front.
You could push the 3 to the front, and then I'd get 3 times, and I'd use that little formula to get the 50-50. And then I'd get 0, 5, 1, 50. Which is certainly going to be faster than plugging in the 1, plugging in the 2, plugging in the 3.
So then why do we learn on the first page that way when we could just take out the 3 and then do this one?
Because if there's only 4 terms, it's probably faster to do it the first way.
So the first way is like,
If
not
the
necessarily a shortcut, but the way you're supposed to do it.
No, because if you didn't know to take this 3 off, the long way to do this problem is literally not move the 3, right? The original way to do this summation is plug in 1, then plug in 2, then plug in 3, then plug in, and then add them all together at the end. Then we learned we could take that 3 and we could push it to the front. But we were still adding 1, then 2, then 3. We just weren't multiplying by 3 yet. Then we're saying if it's just a single variable, now I can use the n times n plus 1 over 2. I'm going to do examples where they're all going to be mixing together, and we're going to see what we can do with them.
Because I still don't understand, like, if the first way is this way,
It's part of that shortcut.
It's, yeah, it's like.
We just combine two shortcuts together by putting the 3 in the front. Does that make sense? So the shortcut I just taught you is if there's only a variable. Then we said, but what if there's a number in the front of that variable? That was a different shortcut. So we just combined those two together.
So like, if, like I forgot or something like that, oh, okay, I could put the variable to the front,
Yep,
solve it as regular, multiply by that.
yep.
Or
It would take you a long time because you're going 1 to 100.
Or if bigger numbers,
Right.
n
Times n plus 1 over 2.
times whatever the coefficient.
Mm-hmm. Okay. Now the second one, now my variable is squared. So this would be if whatever the n is at the top, and then there's an I squared or a variable squared there. So I would have to do the 1 squared, the 2 squared, the 3 squared, the 4 squared, and add them all together at the end. Or I use this little guy, n times n plus 1 times 2n plus 1 over 6. So that would look like this. X is squared here, right? So instead of plugging in 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10, I would do 10 times 10 plus 1 times 2 times 10 plus 1 all over 6. So I'd get 10 times 11 times, this would be 21 over 6. I could say 2 goes into 6 3 times and 2 goes into 10 5 times. And I could say 3 goes into 21 7 times. And then I can multiply that out. So this would be 12 times 11 or 132.
Does the same rule apply for third?
Yep. Push it to the front. The last one is if it's cubed. If I had a variable cubed, I use n squared times n plus 1 squared over 4. So if I had the same thing, 10, I equals 1, and it was cubed, then I would do 10 squared times 10 plus 1 squared over 4. I'd get 100 times 11 squared, which is 121, over 4. 4 can go into 125 times, and then 121 times 25. 25, which is way faster than doing 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus 5 all the way up to 10.
Is there any particular reason that there's like a 4 and a 6 in there, or are those just random things?
I'm sure it was deciphered somewhere, and I'm sure your book has it when you're really bored and you want to read that. The actual derivative, yeah, I'm sure it's there somewhere. Somebody super smart came before us with lots of times on their hands. I think there wasn't an internet back then. They just played with numbers. But why? So that we could do this.
So they can torture us?
Didn't
Yeah.
you realize, like, when the first person to do this, like, they were sitting in the math class with like, now I have to learn this formula that someone came up with, let's make my own. Like,
Well, I think no matter what kind of formula you end up being back to the basics of that,
You know what?
they'd all have to end up discovering about the same formula.
All of these. But in life, when do I use these? Yeah.
Today.
But all of these.
But like, what, like, is there any time that
Let's try to apply what we know about these shortcuts, okay?
I know the first one.
First one,
800.
It's the first shortcut.
that took us 20 minutes yesterday.
You do C times N.
Yep, 5 times 40.
5 times 40 is a big number.
No,
Oh, wait.
200. Wow.
Sophia! No, I did like 5 times.
So, but I'm going to do a variation on this just because we're going to see it eventually show up. What happens if this said 3 on the bottom?
Okay,
Oh.
my guess is you do 5
Minus.
times 40 divided by 3.
Minus 120.
No.
No.
5 times 40 divided by 3?
No.
5 times 40 minus.
Well, how do we figure out the n? How do we figure out the number of terms?
Oh, you only
do
do
minus
it
3.
Top minus bottom plus 1.
Yeah.
40, I don't, if that's what you're trying to say.
Yeah,
M-
makes sense.
40
So it'd be 37.
minus 3, 37, plus 1, 38.
Why you plus one?
Be-
Because you didn't include.
because you have to include the one on the bottom.
Oh,
You're finding the difference between those two, but then you also have to include 3,
okay, so 40 minus 2.
right?
Wait.
If I tell you that there are the numbers 1 through 10 in a box, how many numbers are there? So if I do 10 minus 1,
9.
that's 9. That's not enough. I have to add back in the extra one.
Why?
If you're counting things,
Oh.
right?
Have I been counting wrong?
No, no. It's just if you're trying to count, if you're trying to do the numbers, you can't take the biggest number and subtract the smallest number from it to find how many there are.
10.
10
minus 1. There's now 9.
plus 1. That's how we find this.
Why?
Why are there 10 things now?
Because there were 10 pieces of paper in there, right?
But now I'm subtracting 1 because now there's only 9.
You're not taking anything away though. So there's.
But it said that we're starting from 3. So 40.
Right, so 10 minus, 40 minus 3 plus 1, because you have to include the 3.
3, 4, 5.
Go for it. Go all the way to 40. I promise you I'm right. You could just trust me on this.
I think I've been counting wrong forever.
No, it's just that when you count, you just count what's in front of you. That's simple. When you're trying to figure out how many things there are and you're given the biggest one and the smallest one, you can't just subtract. You have to subtract and then add 1. She's still counting to 40. We'll give her some time, but I promise you this is not, I'm not lying to you.
Okay, 40.
People at home, what do you think their faces look like when we start those conversations? I wanna see their faces, not also because I'm lonely and staring at black boxes, but I wanna see what your faces look like when we start having these conversations.
My prediction is
Because I watch these guys and they watch me, but we only see here up, right? So you don't know what my face is doing down here. But I'd be able to see their whole face, like the mouth drop, the whole thing. All right. What?
I just thought I winked because I went like this.
got that, and
But all she can see is this. All she can see is
She
this.
sees like Raising Cane.
Sometimes I forget you can't see the bottom half of my face, which sometimes is a good thing, but other times it's bad.
All right, let's look at 4. Now 4 is one that is like a combined thing, right?
This, you move the 2 to the front.
Move the 2 to the front.
Yes, and then you multiply 1 times 22. So then you get 22 times 22 plus 1 divided by 2 times 2.
Sorry.
What?
Divided by
Yes,
2
n
2.
times, you're doing n times n plus
Yeah.
1. Okay, but yes. Because it's just a variable there.
Okay, but like, hypothetically speaking, we did not do it that way.
Yes, you
No,
did.
we didn't.
It's
We used n, yeah we did, we did n times n plus 1 over 2.
Okay, but like, if we do not do that.
Then you have to, so you have 2 options. If you don't bump the 2 to the front, you would plug in 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10, then 11, then 12, then 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and then add them all together.
Now you see where I cheated?
If you bump the 2 to the front, you still have to bump the 2 to the front and then add in 1 plus 2 plus 3 all the way up to 22. Or you bump the 2 to the front and then you do n times n plus 1 over 2.
Are we gonna have a calculator for this test?
I don't know yet.
Please. I really think.
I think you'll at minimum have the 4 function on the lockdown. I just don't know how much more you'll have because some scientific calculators have summation on them. And I can't check everybody at home.
Didn't tell us that, none of us.
Oh yeah, you can just tell
Yeah.
us that we don't have that button.
Somebody would figure that out.
Wait, why? Since it's times 2?
Okay.
Since it's times 2, we just go divide by 2 and we leave it, right?
That would be fine too. Yep. So
So it's just 506.
Denominators other than 10 for when you let us use
It's
the
a-
calculator for the log test.
yeah.
I was just doing it's like math, alpha math.
Yes.
And I was like, oh my gosh.
All right, so n is, because the bottom number is 1, n is 22. 22 times 23 over 2.
How do you know what n is? Yeah.
N is the top minus the bottom plus 1. Or if the bottom is 1, n is the top.
Why is there 23? Oh, never mind, just kidding.
If the bottom number is 1, not an L, but a 1, then the top number is your n. If it is anything other than 1, then that's where we do that top minus bottom plus 1.
So, if
Okay.
there's an I next to a number, or just
of just a variable. Could be an I, it could be an X, it could be an A, it could be just a
But it
variable.
has to match the bottom.
It should match the bottom.
Or next to a number, like it could be like I or just like 2I or like 3.
Yes.
If it's that, we use the N plus
Yes.
whatever thingy.
But we have bumped the number to the front first before you can do that.
Okay, but now.
So now this is going to be 2 because this is 2 times this, so it's 2 times this. So you could simplify this a lot of different ways. You could do the 2 into the 22, make that 11, or like Audrey said, what if we can also just cancel the 2's? That's fine too.
22 times 22.
This would be 2 times 250, 3, and then 6, 506.
Why did I put 2 there?
Can I keep going?
The next one
Wait, I
is
don't
using,
understand
I don't
what
get the
the
next one
is.
because it has a colon.
This is a very big number.
It should be 506.
But I know, but like. the-
Oh,
Okay,
so-
I know that we have to.
Hang on, Audrey. So this is the n
Wait.
times n plus 1
Yeah.
over 2, right? And I simplified the 2 into the 22.
So it'd be 11 times 23.
Yeah, which is 253.
Right.
And then that times the 2 that's on the front.
Oh. you
Yeah.
can put it-
Or you could have canceled out the 2's and then just done 22 times 23.
Oh, okay. I think I did it wrong.
Is the next one combining the second one from the second page and the third one from the first page?
I did it very wrong.
There's actually 3 things happening here.
I'm confused.
There's a lot of things happening.
Okay. So if the number at the top, and I'll say it again because you can approach it this way. If the number at the top was small, if the number at the top was 4, I could literally plug in 1, then 2, then 3, then 4, and probably add these together. It wouldn't be so bad. But because it's 14, you certainly don't want to have to plug in the numbers 1 to 14. So we're going to break this apart. Remember, you can break apart the sum and the difference, right? So I could do the sum, the 14, the I equals 1, the 2I squared, minus the summation of 3.
Yes. I am understanding.
That's good.
You weren't here when we broke it apart, but that was what we did. Any kind of sum or difference, you can literally break apart, but it's almost like distributing. They both get the sum,
Okay.
okay? But I'm still not done,
Just saying.
So
because that first number has a squared on it, right?
So it's like the other one.
So now I can bring the 2 to the front.
So neat.
Well, why don't you keep the negative on the, because you're subtracting. Just kidding, just kidding, just kidding.
Mine looks so
Lie, lie, lie.
cool. Look. Helen, it looks neat.
Sorry.
Did you spend the whole method
good
just
job.
doing that?
No, that's this problem.
Okay, how would I find the summation with 3 on the right and the 14 on the top?
Why you put a
Okay,
T?
you do the 14 times 14 plus 1 times 2, 14.
Nope. For the one on the right.
Oh,
That just has the constant.
42.
Oh.
What?
It's just 14 times 3.
I was not doing that.
Yeah, I know. That's why I stopped you.
I'm gonna mess it up though.
Okay, then comes the squared. So the squared was what? Go ahead, Audrey.
So that
Give it to me in n terms before you do the numbers.
2, that's n times n plus 1 times 2n plus 1 divided by 6.
That's your I squareds, right? So the n is what?
The n is
14. Times 14 plus 1, which is 15. Times 2 times 14, that's 28, plus 1, that's 29. Over 6. Minus 42.
Okay, I'm a little bit behind.
Okay.
Minus 32, and then ends 2.
What's in
Is the number at the top if the bottom number's 1.
Okay.
Now I could do 2 into 6 and then 3 into 15. You can simplify that as however you want, okay? I just did 14 times 15 times 29 divided by 6. And I get 1,015. I'm just, for time purposes, I just multiply that out. But you could simplify that out however you want. And that becomes 2,030. And then I bring down the minus 42. And I get 1988.
We
Okay, now this last one, I'm going from 1 to 6. So again, I could take and plug in 1, plug in 2, plug in 3, plug in 4, plug in 5, plug in 6, and then add them all together. So if I didn't know my shortcuts, that's certainly what I would do, okay? So again, I could plug in 1, I would make my I equal 1, I would make my I equal 2, I would make my I equal 3, I'd make my I equal 4, I'd make my I equal 5, and my I equal 6, and then at the end, I'd take all these numbers and add them together. That is one option. The other is, I have a summation here, but there's 3 parts, right? So I can break it apart. 6i equals 1, I squared, plus 6, I equals 1, 3i, plus 6, I equals 1, 5.
What is the bean-shaped thing? Look,
That was me saying you could take all those answers and add them together. Yeah. Oh, this is I squared.
Okay, so basically the one I missed is just like it's like a distribution where you.
Yeah, it's not the distributive property, but it basically is.
It's like.
Yeah.
It is.
It is, but it is not. Okay, so this one we know is 30 because it's n times 5. This 3 would get pushed over here, and that's n times n plus 1 over 2. N, which is 6, times 7 over 2. 2 goes into 6 3 times. 3 times 3 is 9, times 7 is 63. And then the squared is this one. Nope, the squared is my, right?
That's the n.
Yes.
N plus
N,
1 times 2
6.
plus 1 divided by 6.
Times 7, times 2 times 6, that's 12 plus 1, that's 13 over 6. These cancel, and that's 91.
And then 93 plus 91.
184. So honestly, if it's like a 1 to 4, probably I would just plug them in. And especially if you don't remember the shortcuts, you could do that. But the good news is you have these reference sheets, so hopefully by then we're like good on a reference sheet and look at it, figure out from there our shortcuts, and then it saves you a lot of time. All right, the homework is on WebAssign. It is due tomorrow. Okay, you guys have a great day. It's the same one as yesterday. Bye, Brianna. It's the same one as yesterday.
Oh, on the homework, if there's like an exclamation point.
Oh, that's a factorial. That's what else I meant to go over. So if it said 3 factorial, that's 3 times 2 times 1. Yeah. I know it's been a long time since you've seen those. A factorial. So that's not 3. That's 3 times 2 times 1.
So if it's that.
If it was 10, it's 10 times 9 times 8 times 7 times 6 times 5.
So that's like that's the.
It's called a factorial.
It's counting down.
But it's like exclamation point over exclamation point. That doesn't like. Oh wait.
They can't cancel. So if it was like an n plus 1 exclamation point, right? So that would be n plus 1 times n factorial, and then the n factorials would cancel out.